It's my pleasure to introduce a panel that is still forming, please. And I'll start with Lieutenant Colonel Joe Chapa, whom you see on your left. Joe, as you can see, is an Air Force officer. He holds a doctorate in philosophy from Oxford. And his areas of specialty include the just war theory, military ethics more broadly, and of course, he's also extremely adept in the ethics of remote and autonomous weapons. I can attest to that, having had him as a former colleague in our Air Force Academy's Department of Philosophy, where he was our lone Predator pilot then and now. We've never had another one. So we were very lucky. He, under the rubric of Air Force Futures, is the Air Force Chief Responsible AI Ethics Officer, and he works on that cross-functional team in the department. He's a senior pilot, as you can see, if your eyes are as good as his. He has 1,400 hours as a pilot and also some of those hours as an instructor pilot, and many on the Predator as well, but also in those amazing 3D aircraft that the Air Force still has some of. In July, his book will come out, and I can tell you I have an advanced copy. It is very much worth your time. Following Joe's presentation, we have Lieutenant Colonel Christopher Lowrance, and I have been schooled in the pronunciation of his name, so thank you, I would have missed it, who is the Chief of Autonomous Systems Engineering at the U.S. Army AI Integration Center, except for the hiatus that he's on right now, which I understand to be the Army War College, where you're a graduate student. He, like Joe, is not an academy grad. He's a VMI graduate, where he was a distinguished grad in military sciences. And obviously you did tech there and ended up with a PhD from the University of Louisville in computer sciences and engineering. So a very wonderful background. You too have that wonderful title of Chief of Autonomous Systems Engineering that I mentioned, and you haven't only done that kind of work at the center in Carnegie Mellon, but we're also 2 tours, I understand, at the West Point Department. So we have 2 very expert panelists, and I, for one, am looking forward to their presentation. Gentlemen, over to you.
Thank you very much. Thanks for hurrying back from lunch. Thanks to Ed and the team for organizing the event and for the invitation. It's great to be here with you. I have a few different jobs at the Pentagon, and I want to explain those briefly just so you can kind of get the perspective. So I do work in Air Force Futures. That's an air staff organization. I lead the AI cross-functional team, but recently I became the Department of the Air Force Chief Responsible AI Ethics Officer, and that takes place in the Office of the Chief Data and AI Officer, which we call SAF-CO. So you'll notice the slides say Chief Data and AI Office, and I'm coming to you from that perspective. And the reason I mention that is because I'm going to say Department of the Air Force a lot, and it's going to sound obnoxious, like when people tell you they went to The Ohio State University. But the reason I have to do that is because we're now one department with 2 services. So in my Air Force Futures job, I think only about the Air Force, but in this role, I'm thinking about the Air Force and the Space Force. So you've already heard today from one department, 2 services in the Navy and the Marine Corps. They've approached AI really as separate services. We in the Department of the Air Force are trying to pursue AI as one joint team under the Secretary's direction. So that's why you have one representative here from the Department of the Air Force talking about both services. So I'm going to do 3 things if I'm successful. I'm going to tell you a little bit about what's going on in the Department of the Air Force with respect to AI programs, AI developments, things that we're trying to use AI to do. And then I also want to address kind of 2 challenges that I think affect the way that we as a bureaucracy, but also as an organization that cares about getting the ethics right, 2 challenges that we face. And then I'm going to try to show you the way ahead, what I think might be one possible way of addressing some of these challenges. So the first challenge is a linguistic challenge that everyone in the Department of Defense faces, and really anyone working in the AI field probably faces the first part of this challenge. So the linguistic challenge is, what do we mean when we talk about AI? Everyone in the room might give you a different answer, and that's okay. According to the Department of Defense definition, AI refers to the capability of machines to perform tasks that ordinarily require human intelligence. That's a pretty big space, right? When I save words into Microsoft Word, I'm asking the computer to remember more words than I would be able to remember on my own. Does that fit into this definition of artificial intelligence? Probably. So even though we're organized around artificial intelligence, I've mentioned the Artificial Intelligence Cross-Functional Team. You heard this morning from the Joint Artificial Intelligence Center Director. We now have a Chief Data and Artificial Intelligence Office. So we talk in terms of AI, but most of what we're going to concern ourselves with, especially when we talk about responsible AI, is machine learning. So I'm using these terms in the following way. Machine learning is a subset of AI. And the reason machine learning matters to us, both in the systems I'm going to talk about, but also in the ethical discussion, is two reasons, really. One is because of the explosion of machine learning starting right around 2010. And the people in this room will understand that very well. It's really grounded in two things. One was the computing power, the sort of arrangement of CPUs and GPUs that developed additional computing power we didn't have. And then the other is the ubiquity of data. So both of those things are going to come up here in a minute. But then with respect to ethics, the reason we have to talk about machine learning is because of the unintended consequences. Go Google AI ethics, and I bet you within the top 5 responses to your search, you'll see some headlining ethical failure that's centered on unintended consequences. So that's kind of to frame the scope of what I'm going to talk about and what my office cares about. The second part of this linguistic challenge is peculiar to the DoD. Here's the way this story goes. In 2020, the DoD adopted its 5 ethical principles for AI. Our DoD AI systems have to be responsible, equitable, traceable, reliable, and governable. But then we ran into a bit of a snag because people in the DoD, when they hear ethics, oftentimes we think compliance. For instance, I had to get my slides reviewed for ethics. Right? What they're really reviewing for is to make sure that I'm not giving away information I shouldn't give away, that I'm not being paid, for my time here as a uniform-wearing military officer representing the Department of the Air Force, right? That's a compliance challenge. What we're talking about in machine learning is not compliance, it's something different. And so the Department of Defense said, we're not going to talk about ethics as much, we're going to talk about responsible AI. And so I was on the Responsible AI Working Group that developed the Responsible AI Strategy and Implementation Pathway that I understand is on the Deputy Secretary's desk for publication in the near future. Okay, that works. We're okay with that so far. We're going to talk about responsible AI. But then senior leaders, including the Secretary himself, have started to say things like, this is responsible AI, and it's the only kind of AI that we do. Right? Now, what he's really doing is issuing a challenge to people like me to say, make sure that when we do AI, we're doing it in accordance with the AI ethics principles, we're doing it responsibly. But if we're not careful, we could find ourselves in a bit of a loop where we say, wait, if responsible AI is ethical AI and responsible AI is the only kind of AI that we do, then is there really any such thing as AI ethics? And my answer is yes, and I'm going to explain that here in just a few minutes. So just to set the stage with some of the linguistic challenges that we face, but we're going to operate within those challenges, and hopefully we're going to be successful. So the next thing I want to do is talk to you I'm not going to give you the portfolio of AI endeavors across the DAF. That would take too long, and I don't have all those answers. That's a difficult question to ask. What is the DAF doing in AI? And I could talk in the Q&A if you like about why that's difficult. So instead, I just put a few examples on the screen, and I wanted to try to show what we're thinking about as a time horizon. So you already heard today that the National Security Commission on AI challenged the Department of Defense to be AI ready by 2025. We're striving toward that goal. The Department of the Air Force has established a goal to be AI competitive by 2027. So we think about AI ready in terms of enterprise-wide conditions. We're setting the conditions for success. You heard about the stack. I'm not going to repeat that. But we have enterprise-level requirements to be successful, even in discrete AI applications. That's AI ready. And then AI competitive is actually fielding these systems, kind of like what you heard about with the Navy this morning. So I'm not going to talk through all of these. I do want to distinguish for you. Now I'm sort of putting on my A5 Air Force Futures hat for just a second. When we talk about systems, when we talk about capability development, we're talking about the next several years, this year, next year, the year after, maybe a 5-year time horizon. When we talk about concept development, though, we're looking further down the road. So we're really doing two things at once. We're trying to pull industry solutions to problems right now, and then we're trying to affect our concepts, our warfighting concepts for how we perceive the Department of the Air Force to fight in the future. And we're trying to make sure those are informed by what we think the state of the technology will be maybe 10 years from now. So that's kind of a second time horizon. So if you notice the pattern, the things you're seeing on the left are discrete, narrow applications of AI or machine learning to solve discrete, narrow problems. When we start getting to that next 5-year time horizon, it's kind of like what General Groen said this morning about stacking algorithms on top of each other, right? That's when we want to integrate several narrow problem sets, several solutions to narrow problems to try to create broader solutions. Things like JADC2, or in the Air Force we talk about ABMS, the Advanced Battle Management System. That's the Department of the Air Force's contribution to JADC2. Okay, so that's enough about time horizons and the scope. I just want to pick out a couple of examples to tell you about, and I'm intentionally focusing on things that are not computer vision, because as you heard, computer vision is kind of where all of this stuff jumped off from. So you've probably heard a lot about military computer vision algorithms, so I want to talk about some other things. The second one I have listed there is predicting target locations. So as you heard, I have a history in the Predator. In addition to identifying the thing on the screen, that's a computer vision problem, I also need to figure out where the thing on the screen is going to go. And we have had issues with what's called target custody in the past. Maybe the vehicle goes under a bridge, and I'm not 100% certain that the vehicle that comes out on the other side is the same vehicle that went in. Right? We have had sophisticated adversaries that will intentionally switch vehicles under the bridge so that I can't follow the same person I thought I was going to follow. One of the challenges in an urban environment is if I lose custody of the vehicle, I don't know where to look to find it. Think about movies where the police chief says, establish a 10-mile perimeter. Why 10 miles? Because we know they didn't get that far. But inside of 10 miles, we have no idea where they are. Right? Well, if I have historical data that I can use as training data on traffic patterns in that part of the world, then I can have a much better approach to where to draw that perimeter, right? So if I have a history of data on traffic patterns, I can train a machine learning algorithm to say, under the conditions that we see right now, where do we think that vehicle might have gone? Is it more common to go left or to go right at the fork in the road? If they did go left, what's the traffic pattern like at 5 o'clock in the afternoon on a Friday, right? And so we might be able to, rather than do that causal analysis ourselves as human analysts, we might be able to have a machine learning algorithm do that for us. At the bottom of that list of mission systems, I have AI-capable computing. This is really AI-enabling rather than AI-enabled. As you heard, we have to think about software and hardware. That's a challenge on airplanes, right? Because as you heard, software develops faster than hardware. So the challenge is not just to figure out what the computing requirement is today for AI systems today, and then put a box with that computing power on the airplane. The challenge is to be able to develop an agile approach to computing on the airplane so that I can optimize the computing power on the airplane for whatever tomorrow's algorithm is going to be. And that's a non-trivial problem, in part because when we're talking about airplanes, we're talking about flight tests, we're talking about G-loading, we're talking about crash testing, and that's expensive, and it's rigorous testing. So somehow I need to get to a position where I have something like a modular box on every airplane that we can add or subtract computing power as required to optimize for the AI algorithm du jour. So that's a challenge that we're working on. And then under the business systems, I want to highlight the work of the Aircrew Crisis Task Force. So I don't know if you heard, we're short on pilots. And until recently, the only mechanism we had to try to predict pilot shortages was to look at what the airline industry is doing. As you might imagine, when the airlines start hiring more pilots leave the United States Air Force. Well, that's a really rudimentary way to try to predict what the aircrew industry, what's going to happen to our aircrew trying to leave the service in the future. And so we're using some AI tools to try to ingest many, many more data points than that. One of the fascinating things about this was they sent Tiger teams out to interview people like me and said, hey, how much of a bonus would we have to pay you to get you to stay? And then they used that self-reporting data to establish what the pilot training or what the pilot retention bonuses would be. And what they found is that pilots left anyway. So pilots self-reported to some significant degree that if you pay me X amount of dollars, I'll stay. Then they offered X amount of dollars, and a significant number of pilots left anyway. There's something Kantian going on here, right, about when we look closely at our thoughts, we come upon the dear old self, right? People thought they were reporting what their rational decision would be, but it turns out their calculus was something different. We've never had a time in Air Force history where we were manipulating one variable at a time to be able to do a repeatable study to figure out what the effects of all the variables are. So what we might need is a machine learning solution that ingests all the variables, looks at what the output was in pilots leaving the service, and then comes up with a prediction of what we would have to do to those variables to get pilots to stay. I just wanted to mention those three. There's more we can talk about in the Q&A if you want. But I also want to mention a bureaucratic challenge. So I mentioned the linguistic challenge. I mentioned some of the systems. Then how do we do ethical AI as a department of the Air Force with 600,000 people? It's not easy. One of the challenges is that if you look at kind of the literature on ethics and AI, we tend to find these case studies that make it look like we have a developer, we have a sponsor, we have an operator, a user, and all those three people are in the room in the DevSecOps environment producing these systems. That might be how it works in industry. I don't know, you'd have to ask an industry person, but I will tell you in a 600,000 person organization, these people are not all in the same room. And so we've distributed what the sponsor wanted, what the developer's developing, and what the users are actually doing with the system, those are distributed across time and space and bureaucratic parts of the institution. And so if intentions matter, which we heard about from the Marine Corps, right? If intentions matter, well, then we want to talk to the sponsors. What did they intend by the system? But if we're worried about unintended consequences, then we need to care about what the developers are doing. And if, as you heard in the case of, for instance, Maven that performed extremely well in a desert environment but then didn't perform well in an Arctic environment, well, then we need to ask, what are the operators actually doing? And we can't ask any one of these questions and hope to get to a good answer. So this is the challenge that lays before us. I'll tell you, just last week I had an email from someone where we're trying to look at an application that they're developing on the business side to sort of evaluate it for responsible AI. And I said, it'd be great if we could sit down with the developers and talk to the developers. And this person said, you don't want to talk to the developers, you want to talk to the people who wrote the requirements for the developers. And actually the answer is I need to talk to both, right? I need to know what the requirements were, and then I need to know what the developers were doing. I, the philosophy person, by the way, I'm not looking at the code. I have a data scientist that can help me with that. But with our powers combined, we should be able to talk to both teams and then ultimately the end user. So that's the challenge. What are we going to do about it? This is notional in the sense that the Secretary has not approved this yet. We have pitched this to the Secretary and he has expressed interest. So just take this as kind of the way that the Chief Data and AI Office is thinking about pursuing responsible AI. I mentioned several offices and several documents. I won't go through those again, but I think what's missing in the DoD right now is a risk assessment for responsible AI. There are several efforts to create a kind of a cap or a gatekeeper function. You heard a lot this morning about 3000.09 and its relationship to autonomous weapons. As you heard from Paul Shar, 3000.09 does not prevent you from creating Terminator. It just imposes a review process if you do create Terminator, right? But that's still a binary calculus, right? You will go through that review process and you'll get a pass-fail from the tri-chaired committee. What I think we need is a risk assessment with respect to responsible AI. Let me give you one example and then I'll get off the stage. There is a capability that we have it's reached initial operations capability, IOC, it's not FOC yet, and it's called Global Synthetic Weather Radar. So essentially what they've done is they've taken data that's already correlated over CONUS that says I've got weather imagery from space, and I've got radar returns for weather radar. I can use that as a training data set. It's labeled data. I can use supervised learning to train an algorithm to take an input from satellite imagery and then produce what it predicts the weather radar should look like. If you live on a planet that's covered by 70% water, that would be a really valuable tool, right? Because now I can predict what the weather radar looks like, including precipitation over the ocean. That model was trained using a deep neural net that's not explainable. You heard about explainability earlier today. So if all we have are the DoD's AI ethics principles, one of which is traceability, you might think that we operate under a regime in which we can't use that weather tool because it's not explainable, it's not traceable under this principle. What I would like to get the Department of the Air Force to is a place in which we can run this review process and then hand back to decision makers a risk assessment that says, look, if you employed this system that was trained on a deep neural net that's not explainable, you are accepting risk, because when you have failures, you won't be able to determine the cause of the failures. If that's a risk you're willing to accept in this environment, then that's a commander's decision to make. And the reason I say that is because, to me, there's a huge difference between employing a system that's not explainable to do, for instance, autonomous target recognition, right? To decide what things are going to blow up. Between that and employing a system to predict what the weather radar looks like. And I think if we're not incorporating that level of nuance into our decision making, then we're going to miss out on opportunities to employ machine learning in ways that are advantageous for the department. So this is where I'd like to go. We're not there yet. I'm happy to take questions on it if you have them. And I'm going to stop there and turn it over to Chris. Thanks.
All right, thanks, Joe. Good afternoon, everyone. Thank you so much to the McCain Conference for the opportunity to speak to you today about AI. And so in the broad sense, once the slides come up here, and I'm going to grab them. Sorry about that. So I'm going to talk to you today a little bit about some application areas for the Army, but really more broadly applicable to the Joint Force as well. And really from an operational standpoint, let's imagine like a joint operational headquarters. And for some of you, some of this might be a review. For others, hopefully it's a little bit more educational and give you some information that you can use to help inform some of your discussions about ethics. And Joe stole my slide earlier. So most of you all probably already know about the idea that deep learning and machine learning is a subset of artificial intelligence more broadly. But I do want to highlight a couple of examples of algorithms that are quite useful still in the broad area and domain of AI. And that is, for instance, game theory. Game theory can be very applicable to you're looking at strategy, right, for maybe a course of action recommendation engine, and potentially other types of techniques of AI or optimization algorithms that can go through and optimize a cost function, for instance. So, for example, think about logistics and the challenge of getting the right supplies in the right place at the right time, and the whole trail of that logistics train and what supplies you put on the back of the truck or the airplane. That's a combinatorial optimization problem, and AI is well suited to type of solve that. Now, in deep learning, what you're going to see is this concept of using AI in the sense of using artificial neural networks. And these consist of, many of you all already know, a layer of neurons. And essentially, it could be many layers, hundreds. And when you look at all the parameters that go through, you're talking about a series of interconnected layers where the inputs, in this case, a picture or image, the pixels are being weighed at different weights and different values. So you basically have a multiplication process that's taking place, as well as biasing and summing of this. And you're talking about potentially millions of parameters that are being tuned to ultimately to take that input, that raw pixel data, filter it through the neural network to ultimately lead to a classification. And so in general sense, deep neural networks are broadly applicable to many types of classification types of problems, but machine learning can also do other types of problems like regression. And let's talk about a specific example. So you maybe heard the term supervised learning. Supervised learning is the case where you actually have training examples to teach your AI. And so as you see here, let's assume that we have a predictive maintenance example where we have a database at our disposal. And if you look at the database, you have a series of columns and rows. And if you look at that, you have within there, if you take the left-hand side of all of these columns, you can use that information to potentially feed and predict an output variable. And each one of those rows, you could be maybe a sensing example. So if you take a ground vehicle or an air platform and you wish to predict whether a part needs to be replaced or not, you're going to have to get, and assuming the vehicle has been instrumented with the right sensors, you can read that data. Each individual row in that database is a new instance of information, right? And so in each column is maybe a different type of sensor. And then that's going to provide you an input, let's say a vector of input, multiple features that you can use to teach your AI algorithm ultimately to predict that output variable Y, i.e., do I need to replace my part or not? Right? And do that more of in a predictive fashion rather than just basing on a time-based maintenance schedule. And then the machine learning algorithm, its job and responsibility is what you see in the center. It takes that raw information of training examples and finds a mapping function from those series of inputs to the output. And we might not necessarily have the ability to measure everything, right? So there might be some missing information, but the machine learning algorithm, in a general sense, will build an approximation function. And that approximation function will have a degree of correctness or accuracy. And you can measure that using a holdout of information set that you can test and evaluate your algorithm once it's been trained. And once that algorithm has been trained, you see on the far right, you can deploy that. And you can make predictions on future cases. So does a part need to be replaced or not? And there's a caveat, right? The new data that goes into your trained model needs to be representative of the data that's trained the model. If not, you're subject to degradation and potential errors in your function. Now, you can extrapolate this out to many types of different use cases, and Joe briefly mentioned this. It goes by different names, ATR, aided threat recognition, or automatic target recognition. So imagine that you have a series of images, and you can annotate those images using a series of bounding boxes like you see in this image here. And that's generally a human process. There are some techniques out there to automate some of the labeling to help expedite and speed up the process. But generally speaking, it's still a quite large human quality control process that has to go through and visually inspect. And you can build a large pool of these images. And you're talking on the order of thousands. And once you have these images, again, you can feed that through your deep neural network, for instance, and through an iterative process, all of those weights and biases within each neuron, those millions of parameters get tuned ultimately to make an output prediction and get you your trained model. And then if you have your trained model, you can deploy it and then start to actually do some inferencing, right? And do some prediction of, is this particular target that I trained the algorithm on present in the image or not? And one thing to point out is that the algorithm itself can give you a level of confidence that it got its prediction correct or accurate. Now, you can imagine taking that kind of concept, exporting it out to multiple different types of systems, right? All different types of systems and sensors, all the way from space, air, ground, and so on, through the various domains. And now you're going to have the ability to really get unprecedented situational awareness and through these algorithms. And you can imagine that now these sensors that are potentially running AI algorithms at the edge, on platform, or potentially centralized, that is feeding ultimately a common operational picture, and really could be auto or really with a soldier or human in the loop that's verified and before it actually gets populated to the common operational picture. And I would be remiss if I didn't actually bring in Carl von Clausewitz, right, as a War College student currently. So he talked about a concept called coup d'etat, and it's the ability to get a comprehensive view of the battlefield at a glance. And from that glance, you can glean from there maybe decisive points of where you can go ahead and take advantage of opportunities to give yourself the competitive advantage. Well, what does that look like in today's modern battlefield? It looks like a single pane of glass, like I just discussed previously in the slide, that this unprecedented situational awareness of all of these sensors across the battlefield, using AI to quickly process that information and give us the potential target detections on this kind of view. And now, with that, however, we can't necessarily guarantee that AI will lift the fog of war completely, right? But what can we do to mitigate it? What we can do is start to leverage sensor fusion, and AI can also potentially help with this as well. It's the concept of combining multiple sensor feeds together to give you a more accurate or more robust detection of the potential targets. So as you see in here in the image, you have potential satellites giving you maybe geospatial intelligence, the processing of that information. When you couple that with, for instance, SIGINT or signals intelligence or electronics intelligence, that's going to enable you to have a better quality detection if you fuse those together. How many of you, just to kind of take a quick poll, how many of you heard of Project Convergence in this audience? Okay. Roughly about at least a quarter. And so Project Convergence was born out of Army Futures Command, and it was really the idea of being able to test some of these future systems that are being, as part of the Army's modernization priorities. The Army has 6 primary priorities, and then also testing out some of the future concepts that are really underpinned with AI as well. And it's dubbed as a campaign of learning, right? So we're experimenting with some of these prototypes that are leveraging AI, and ultimately what you're seeing as the goal is how can we shorten this sensor to shooter cycle? You know, how can we go from the order of minutes potentially down to seconds, but do so obviously in a responsible, ethical manner? And what does that appropriate level of human oversight look like? And so this is part of that experimentation process. And one of the big themes is finding, you know, any sensor to the best shooter through the right C2 node. And just to give you something tangible to work with, I put this slide in here just to talk about autonomous systems, right? So picture a scenario where you have a team of collaborative air and ground platforms that are able to autonomously maneuver in a reconnaissance type of mission set. And then, like I discussed before, using ATR, as the slide shows here as well, to auto-detect various targets. Now, AI also really enables the autonomy of these vehicles. As you can see from the picture on the bottom left, this is using semantic segmentation. It's the concept of taking every pixel in that image and associating it with a class, like a terrain type. And so in this image, you can see that the AI classified what is the road, what is low vegetation, what is large vegetation, and from there, the system can build a cost map, right? What terrain is maneuverable, what is not, right? And so using AI-based computer vision enables these systems to be autonomous. And that will allow the cognitive load of the warfighter to go down, right? Because now you can have this concept of, let me give the system some broad intent. And like, for instance, draw a polygon on a particular map like you see here on my common operational picture and give it some rough guidance to say recon in this area. And then from there, you can be hands off. You can be one, let's say, warfighter to many systems, and then you're not necessarily have to sit there and teleoperate those systems, and they can provide you that, enhanced situational awareness. And one type of interface is Android Tactical Assault Kit. And so that's what is born out of the soft community. It's like your Android device where you have like I said, a common operational picture, a map information, and you can go there and you can do some various button touches or clicks to sketch, like, for instance, a polygon for the systems to go recon. And you can click on there as well and get an image back of the system when it detects a potential target. And you can use that to verify, is this a legitimate target or not? And so I put this in here to kind of give you some food for thought in terms of oversight. What is that interface to the systems? And what does that look like to give a meaningful or appropriate levels of human oversight? Another one is the Integrated Visual Augmentation System. And that is called IVAS. That is targeted for the infantry warfighter. And it's an augmented reality headset. And you can imagine once you give guidance to these systems, now potentially through voice, the system has the capability to do voice recognition. So you could imagine being augmentation in your field of view. Maybe it's an urban environment, a building that's labeled, like building number 1, 2, or so on. And you can give your system to say, recon beyond building 2, 500 meters. Simple guidance like that, and then the systems can interpret that using AI, and then, really effectively through mission command, meet your intent and execute that mission without further guidance. And meanwhile, they're using aided threat recognition to detect targets and potential threats in the area. And so, again, I think the next step, evolution of this, is have that picture image or chip image coupled on your field of view, and now you could potentially validate targets, because that's going to be a key. If you're actually going to fuse sensor to shooter, right, you need to have the appropriate levels of validation, not just being completely human out of the loop or on the loop, but actually validate that chip image and say, yes, the system got it right, or no, it didn't. And so as we start to look at this, you can start to look at and frame this under the auspices of the targeting cycle. And one of those targeting cycles is known as F2T2EA, or find, fix, track, target, engage, and assess. And I highlighted here areas that are probably ripe for AI, and you can see that in the blue. And then other areas that are really probably should be reserved for a human in the loop to verify. And some of these are augmented. Other times, it could be expedited and based on best judgment, confidence of the AI, risk of the commander, and so on. But you can see that the red boxes there, like authorizing and verifying, would be reserved for a human, just like I previously discussed, right? Looking at maybe, for instance, that chip image to verify whether the AI got it wrong or right. And I use chip images because pushing full motion video from these systems in a very contested environment, if some of our peers have capabilities for jamming and so on, we need to be realistic about what kind of bandwidth we're going to have available at our disposals to basically see to autonomous systems like we just discussed. And so one of the steps you saw in there was solution pairing under the target umbrella. This is an optimization problem, and this is just a few of the criteria that you might want to try to look at and optimize. AI, like I discussed before, as part of artificial intelligence, does a really good job of optimization, solving optimization problems. And it could ultimately find potentially the best shooter that's out there for a particular target. But it goes beyond just finding the single best shooter. If we look at our new concepts that are out there, like multi-domain operations, joint all-domain command and control, and so on, it's the concept of really getting a convergence across multiple domains, right? And now if you're starting to present the warfighter with thinking cognitively about what effects can potentially be applied across multiple domains, that's a very challenging problem. And getting the coordination of those effects across multiple domains is again, very challenging. So can the machine help with that to achieve the concepts that we're aiming for? And I put this slide in here just to kind of show you how complex a battle space might be, right? How many shooters are potentially out there, what systems, right? What sensors and so on. And trying to stitch all that together at a human cognitive level is very, very difficult. And I think also the other challenge we need to talk about is the right of C2 node, right? The right authorities. So if you're the platoon leader at the tip of the spear and you have that autonomous systems, air and ground platforms we talked about, and you gave them a reconnaissance mission and you validate through the chip image that you have a valid target and you want to affect, who's authorizing, right? The Air Force F-35 that's in the area to release its munitions, right, on that particular target. So those are some challenges we got to kind of work through as we're looking at this problem set. And ultimately, AI is, it's going to be making us operate much faster, right? Ultimately, it's about, speed, range, and convergence. And if you look this and frame this through the OODA loop, right, John Boyd's OODA loop, being able to sense, observe, orient, decide, and act, the machine can help us kind of make sense of all that friction that's going out there on the battle space. And looking a little bit more strategically, or at least at the operational level, just another quick poll. How many of you have done wargaming? Okay, fair amount. So that is a human-driven process, right? It's a very cognitive, intense process as you're starting to look strategically at operations of what are your areas of interest, what are your strategic areas that you wish to protect, and trying to understand how you're going to maneuver in a space like this can be quite challenging. And so can AI potentially be leveraged in this aspect to kind of sort through millions of iterations of possibilities to kind of weigh what might be the most effective scheme of maneuver and operational approach on the battlefield? And that's possible through what's a concept called reinforcement learning. And reinforcement learning is the way of machine learning for the machine to learn through trial and error. Effectively, you have a simulation engine, you have an AI agent, and they interact. And based on the state information that the AI is sensing, it will make a decision. And that decision will either be rewarded or penalized. And then over time, numerous iterations, the AI will develop an optimal policy based on the environment that it's facing. And so we can do this if we have a good simulation engine in the military that mimics the type of environment at the right operational and strategic level that we wish to warfight at. And just to wrap things up, I know I gave a little bit of sampling of multiple opportunities. I think you saw probably at the ground, operational level, even across multiple services across the Joint Force. And if I look at the joint shops, I just kind of have a laundry list of potential areas where AI can have a near immediate impact. And the ones highlighted in blue here are the ones we did not discuss. So happy to discuss those in the Q&A session. Thank you.
Sure.
Yeah, thank you. I'm Dan Saxon. My question, I guess, is for Lieutenant Colonel Chapa, and I guess it calls on your philosopher's hat as well as your military officer hat. Walking up the road this morning to the conference center, of course, I passed by the cemetery that's just meters down the road, and there are a number of headstones of young men and women who have died since September 11th. And I noticed that on a number of those headstones, there's a single word, epitaph. It just said, warrior. And what I'd like to ask you is whether you think as the race to deploy and employ more and more autonomous weapons, will the warrior class, as we know it now, will it disappear in the next 10 or 20 years? And if so, what will take its place?
Yeah, thanks for the question. It's a good one, and it's one I've started thinking about a long time ago because this conversation was ignited by remote warfare before it was ignited by autonomous warfare. So have we sacrificed what it means to be a warrior by having folks like me fly a Predator from Vegas when the war is taking place in Afghanistan, for example? I've thought a lot about this. The answer might not be one that you like, but I think if you really take an honest look at 21st century warfare in the United States military, I think we already see so many differences in shading and what it means to be a warrior, right? So do we really think that the warrior ethos for an F-16 pilot is the same as the warrior ethos for an infantry marine? I think in practice the answer is no. And so now that by itself doesn't mean that we aren't at some paradigmatic shift that's going to challenge the warrior ethos at a fundamental level. Maybe we are. But if we are, I think that discussion should at least be informed by the fact that we already have really many different warrior ethoses. Obviously, they share some things in common. But one of the things I do think is that, for the last 20 years, remote warfare has been the exception, right? We talk about Predator and Reaper operations as being different from all the other things that we do. I think over time that's going to become the rule. So if you look at, for instance, we have cyber warriors in San Antonio or at the National Security Administration. When we talk about the distributed environment in a future conflict, we tend to talk in terms of those who will be kind of in the threat ring and those who will remain outside of the threat ring, supporting in an area where comms aren't contested, for example. And so I think what we're going to have to wrestle with is, as an institution, how do we instill in our young members whatever it is that they need in order to be able to do this job well and honorably. And it might be the case that what they need is different from what airmen and guardians, in my case, needed after September 11th, or different from the warrior ethos that was required to storm the beaches at Normandy, right? It's possible that maybe these things change over time. What I don't want to do is be at the end of the whip and just sort of wait to see what happens and then have to play catch up on what the warrior ethos is. So I think we as a profession of arms have hard questions to ask ourselves about what do we want to institute in our future officers and future airmen, guardians, Marines, soldiers, sailors, so that they'll be able to handle these challenges, even if it is at a distance, even if it is remotely and sort of mediated by ones and zeros. Yeah, George, go ahead.
A quick question for both panelists. George Lucas, by the way. It is based on the principle that's fundamental in AI that machines do things that people do, including reason and learn and so forth, but they don't necessarily go about doing them the same way. And I wondered if in the course of your services working on integration, convergence, coordination and so forth, even strategic planning and battle gaming, that you would come across instances where when you integrated AI into the process and took advantage of its capacities, you also, this is not an emergent behaviors question, more novel solutions like playing Go in the new way that had never occurred to a human being as AlphaGo did, and say, wow, I never thought of that, but how totally cool, that's amazing. Did you ever have this happen with some of your military tactical maneuvers that may be AI enhanced, that you saw them just going about this in a completely different way, lacking your horizon of assumptions and coming up with solutions that you could understand but would never have occurred to you, left to your own devices?
Sure.
Great question, and I think you're absolutely right. Right now, I know the Army and probably the other services are going through a deliberate fashion of experimenting with these systems. I talked a little bit about Project Convergence, and really that's more than just an Army endeavor, right? We invited our joint partners to participate. Obviously, if you're going to look across multiple domains, you got to look across multiple services. But part of it is also really the soldier-centered design for the Army, right? It's the warrior-centered design for the other services. And getting that feedback early on, because you're right, they're going to have great ideas. They're going to see uses for the system that you didn't anticipate. So it's better to anticipate those kinds of changes early on. But I think there's other examples out there. For instance, I maybe give you one. a small robotic platform known as the small multipurpose equipment transport, having a tether right on the vehicle. That could be kind of a beacon, right, of where your position is, and at the same time, if you can see it, can you start to use these systems to deceive the enemy, right? A lot of times when they were designed, it's like, hey, this is going to go do a reconnaissance mission for us or whatever, but then there's all kinds of other tasks that they can perform that wasn't necessarily a part of the original intent, but it's morphed to that because you incorporated the warfighter earlier in the process of the experimentation, right? And you're saying, hey, well, we can use this for deception. We can use it for electronic warfare, right, and jamming through our drones that we're going to send forward and so on to obfuscate and confuse and deceive the enemy. And so I think there's a lot of examples out there of that. But I think it's important, though, the big lesson takeaway is that we incorporate the warfighters into experimentation as early as possible.
I don't know if this answer will get exactly to the heart of the challenge, but one thing that came out of our partnership, the Department of the Air Force has a partnership with MIT. We have a small cohort of uniform-wearing military folks at MIT proper. It's called the Department of the Air Force AI Accelerator at MIT. So they take real immediate challenges across the department and then try to come up with rapid solutions to those challenges using the help of world-class researchers at MIT. And one of the things that came up there was actually a responsible AI project that was in support of the global synthetic weather radar that I talked about. So I mentioned that deep neural net. One of the things they were able to do is, with the help of the researchers at MIT, they developed a new technique for employing a deep neural net. And this is much closer to Chris's expertise than mine, so I'll just explain it in the best way that I can. Essentially, rather than having, you saw the picture that he showed of kind of the deep neural net with all those neurons attached in different ways. If that entire net is operating sort of at the same time in parallel, that contributes to the lack of explainability, right? Because now you can't trace the causal relationship back all the way from the output back to the input. And the technique that they developed was to have only certain parts of the neural net light up at certain times. And so it did two things. One, it reduced the power requirement to employ the neural net, which saves money and time. But it also increased explainability, because if you only have one or maybe several rather than hundreds of those pathways employed at any given time, then you can go back and explain how you got from input to output. So it was a real success story for us because it contributed to a real operational solution, a solution to an operational problem. It was developing responsible AI, and it resulted in academic publishing for MIT. So it was kind of everybody won in that scenario, and it highlights the value of our partnership with MIT. Sir, go ahead.
Thanks, guys. I really enjoyed both your presentations. Steve Woodside, West Point. Lieutenant Colonel Chapa, I like the idea of the risk assessment. I was wondering if you had considered, or maybe ought to consider, that these different AI ethical principles would be weighted in computing this risk assessment. And if so, if you have some initial thoughts on how that might look, not down to the precise weighting, but something like that.
Yeah, it's a good question. The short answer is I haven't given that a lot of thought, but I think the answer is going to be contextually defined. So it's going to depend on several things, including what are we anticipating this system doing. So just to give you one example, if you read the Deputy Secretary, so the Deputy Secretary reaffirmed these principles in 2021. So if you go back to that memo, for instance, and read the definition of governable, governable really is putting an emphasis on failing safe, right? An AI system is governable if it fails safe, if you can kill it, right? And the idea is that you don't want to, for example, have a weapon that's driven by a machine learning algorithm in a contested environment where I'm no longer in a position to say, hey, the situation has changed, right? This is a kind of absurd example, but you can imagine, let's say, a loitering munition that can fly for 24 hours. If we reach a peace agreement before the end of that 24 hours, it's very important for me to be able to turn that thing off, right? So in a case where we're talking about stuff that blows up, I think I would want to weigh governability pretty high, right? I would want to make sure that I have the ability to kill that weapon system manually. If we're talking about other contexts, let's say a business application where I'm trying to predict the future of aircrew management, well, that becomes much less important. So I think we could come up with a scheme for weighing them, but I think that the weights would change depending on the operational context. Yeah, Jesse, go ahead.
Jesse Kirkpatrick, George Mason University. Questions for Joe, and it's on. It's adjacent to the risk assessment. So I'm actually. This isn't the view that I share, but I'm sympathetic to it. So I'd like to hear. I'm sympathetic to a risk assessment, but I'd like to provide a potential challenge to it. And one might be that if we consider different weights, as you suggest, that we might also have different circumstances in which the other, every risk is going to have the counterpoint of what the payoff is. Right? So we could imagine a particular set of cases or scenarios in which someone might say the risk is pretty high of getting this wrong, or of having the system not be traceable, auditable, and so on and so forth. But the payoff is also really high, right? And we could, if one thinks of the ethical AI principles as being kind of red lines, right, that one doesn't cross. I wonder if then that the opening up a risk assessment and giving these weights, if we start to run into potentially dangerous territory or slippery slope, and eventually we're sort of haggling over price as opposed to reaffirming principles.
Yeah, that's a good, important challenge. So I think my response is informed by this event that I participated in. We heard about DoD 3000.09, right, which is the DoD directive that governs autonomous weapons. The review process that's defined in that document has never been actioned. So the document's been around for 10 years, and we've never actually had a system go through the review process. And so there was an organization that said, hey, what would that look like? So they came up with a notional system, and then we got people to play the different parts, right? We didn't get the actual principals, but we got deputies and things like that. And I just got to kind of sit in on the discussion. And one of the really interesting things that came out of that is that this notional system really couldn't do discrimination. It really wasn't very good at making sure that it didn't get false positives about potential adversary targets. And so the operational context was, don't worry, we're building this thing to be employed in this very small corner of North Korea, let's say, where it's nothing but rocks and missile launchers. So even if we miss, we're just going to hit a bunch of rocks, everything's going to be fine. And so one of the things that came out of the discussion is that the review process is not really designed to scope the application to a specific context. The review process is designed to grant authority to the service, let's say it's the Army, and say, okay, United States Army, this thing is approved for you to go build and test, and then you have to come back and get it reviewed a second time. It doesn't say you can only employ it in these contexts. And so what I think the risk assessment does is it helps to put some fine shading on a question like that, right? So if instead of having the binary pass-fail like we have in 3000.09, if we have the risk assessment, it puts us in a position to say, okay, just so you know, in the situation that you briefed, this might work out just fine. But warfighters will figure out novel ways of using the tools that we provide to them. I'm okay with that. I encourage that. That's part of the innovative spirit that's going to help us to be successful. But I would hate to have a commander try to innovate with a system if no one ever told him or her that these are the risks, right? So all I'm saying is that I want that innovative commander to have all the information possible before making a determination like that. So I think the pass-fail system matters. I just think we can add to that system with the risk assessment. Anyone else? Yeah, Ed, go ahead. Oh, I'm sorry. Go ahead, sir.
Yeah, Greg Reichberg, Peace Research Institute, Oslo. Just on this risk assessment point, my question was kind of preempted by the previous one, but the EU has a new law under elaboration called the EU AI Act, and the risk assessment approach is at the heart of the law, and the idea is to put technology types, these are consumer technologies, AI related, into like a typology of low, medium, high, unacceptable risk. And then I know someone who's in the Indian military, and he started to classify AI related military apps according to this, the typology. But then it struck me that one significant difference between, say, a consumer technology and a military technology is that in a military setting, risk is a factor of the mission's importance. So you're willing to assume more risk if it will make a crucial difference. So I'm just wondering whether you've got that, that's part of the analysis, the nature of the mission and the assessment of the mission's importance.
Yeah, absolutely. Did you have comments on that?
You can go ahead.
So I agree with that. I consider that discussion of the risk-reward calculus to fall under the proportionality requirement under both international law and just war theory. So I would expect that, let's call it the Combined Forces Air Component Commander, let's say for the Indo-Pacific Theater, I would expect that person to want to have authority to either dial up the risk in a manner of speaking, to accept more risk in order to achieve the mission success, right, in order to achieve the desired effect, if the consequence for failing to do that is sufficiently high. And I think commanders do that already. We already ask commanders to make proportionality calculus. It's always value-laden. It's always a judgment call. And in some cases, reasonable people disagree. I mean, I don't mean could disagree. I mean, in fact, reasonable people disagree as to the call, and then it falls to whoever the relevant commander is to make that determination. So I would incorporate this into that scenario. So I can imagine that we have a machine learning system that does aided threat. What was the term?
Aided threat recognition.
Aided threat recognition, which I think is a helpful term, right? Because when we talk about autonomous target recognition, it sounds like we're trying to shoot someone. If it's aided threat recognition, then we might just be trying to build situational awareness, right? So if that's the function of this system, and then let's say we are watching the invading force sail across the Taiwan Strait. I could imagine that a commander might say the cost of failing to achieve success in this mission is sufficiently high that I'm going to enable that system to have the firing authority, right? I'm going to go guns hot on this system because the consequence for failure is so high. Whereas if the consequences, if the context were different, the commander would not be willing to accept that risk. But I put that all under the proportionality column.
And I'll just offer one thing. I know Dr. Tony Pfaff is going to talk some more tomorrow about this, but one piece of information when you're talking about risk and trying to gauge that is you can also leverage the confidence of the AI, right? And so the last neuron layer can be that output that's triggering the final weights, if you will. The output can be normalized through a function and basically give you a sense of probability that did the AI get it right or wrong. And if you can kind of combine that with the commander's risk assessment, you can make a more intelligent decision potentially.